Hello, I'm Bradley,
And I'm Joseph.
and together we're Siblings in Science. And today's topic is
Rockets and how rockets work.
so we're flying out of this world,
Quite literally. So,
quite literally.
what um, what rockets depend on is a principle that has a really fancy name, but it's actually something quite simple. It's called the principle of conservation of linear momentum.
It's quite a tongue twister for what is quite a simple principle.
Yeah. So that happens quite a lot in physics. There are complicated names for concepts which are quite simple, and the reverse also holds true as well. So I want you to sit there, and I want you to imagine you are standing on some ice, okay?
Yep.
And you are holding a bowling ball.
Okay. I've never
Okay.
been in that situation before, but I'm imagining.
So I'm not sure many people will have had a bowling ball on ice. So that would be quite dangerous, probably. So imagine you are there on some ice and you throw the bowling ball to me. Okay?
Bowling balls are pretty heavy, and you wouldn't
Y-
want one to hit you in the face.
No, that would be painful.
Okay.
I think,
So I'm imagining that I can throw a bowling ball to you, and you would catch it
yeah, me catching it is actually irrelevant.
on the
You
ice.
could just throw it,
Okay.
and that I'm there for support. I'm not relevant to this discussion.
Okay.
Um, so you throw the bowling ball, and what happens to you?
Well, so the ball goes forward, and so I go back.
Yeah, exactly. So you would go in the opposite direction to the direction you threw the bowling ball.
Yeah.
Okay? So this principle is the principle underlying the conservation of momentum. It basically says if you throw something in one direction, you move in the other direction.
Okay.
Slightly more complicated than that. There's an equation, but that is the part of this concept that we need to understand rockets.
Okay.
Okay?
And how does that
And
concept relate?
to rockets.
Yeah.
Yeah. Okay, so to rockets, we so you often see pictures of rockets or videos of rockets, them taken off from a launch pad. Okay, and it's a misconception that you need to be in air or in a position where you have something to push off, I guess, for a rocket to work. And this was actually this misconception was held by many of the founders of rocket theory, I guess, and they were quite unsure about actually if rockets would work out in space. But as you know, they do work out in space because they move from the Earth to the Moon.
Yeah.
So what happens is you have a rocket, and do you know what the main component of a rocket is, or a very large component anyway? So why do rockets have to be so big?
Because of the fuel.
Exactly. So they're carrying a lot of
Yeah.
fuel. And what they do is they throw the fuel out in the opposite direction.
Yeah.
So they throw it down, and because they've thrown it down, they go up.
Yeah.
So this is that whole conservation of momentum thing again. They throw something down. That means there's a momentum going downwards. So the rocket counteracts it with a momentum going upwards. So it moves up. Now, this holds in a vacuum. We haven't discussed, or a vacuum being something where there is literally nothing else except for the rocket and the fuel. We haven't assumed it's not pushing off anything here. We haven't taken air into consideration. The simple fact the rocket throws the fuel in one direction, it moves in the other direction. That is how rockets, on a very basic principle, work.
Okay. And how about these technologies which are trying to use other components to fuel to lighten the rocket, do they work in a very similar principle?
Okay, so yeah, so if you wanna use different so there are like solid fuels, liquid fuels, etc. And yeah, so the lighter the fuel, the bet well, yeah, so if you it depends on how much momentum you can kick out the back, to whether if it's going to be an advantage or not. Simply having a lighter fuel and not being able to kick the same amount of momentum out the back is not as a good thing. But light fuels obviously make it lighter for the rocket to go up, and you need therefore less thrust. So there's a balance of things which would have had to be taken into consideration when considering the use of light fuels, of like how much thrust it gives compared to its weight.
Okay, but the underlying principle of how rockets work is actually quite simple.
Yes, it's very basic. It it can be done on Newtonian mechanics. So very like mechanics that's sometimes taught at schools, not even university level. It's the principle of rockets. Although rocket theory is said to be incredibly difficult, it's incredibly difficult if you're going into the massive amount of detail. If you want to actually make sure that people don't get hurt and you're designing a rocket, that is incredibly difficult. But the underlying principles to understand how a rocket works are quite simple.
So the theory is simple, but putting the theory into practice is the difficult part.
Yeah, so it's building rockets, making sure they work and stuff. It's the engineering component of it that's difficult.
Well, and now you know that the next time you see a rocket launch, that it is just as simple as that. But also, it's important to remember the amount of people and teams it takes to get these things up and launched in the first place. And so, on that note, we've been Siblings in Science. Please follow us on Twitter at Siblings in Sci, and go to our website, siblingsinscience.com. See you next time. Bye.